What is Kafka? To understand Kafka, let's take an example of a chat application. You have a user and a chat room. In this case, it's a public chat room. A user connects to the chat room and starts sending messages. Messages arrived in sequence. On the other side, we have another user who also connects to the public chat room and start receiving messages. Because it's a public chat room, other users can also see messages. However, user can also connect to the private chat room where messages can only visible for approved users and not to anybody who uses a chat app. How this is related to Kafka? Well, the user who is sending messages called publisher. The users who receiving messages or subscribe to the chat room called consumers. And the chat room itself is called topics in Kafka. Let's take a deep dive and see how this actually works. We have a producer called Twitter application who send messages as and when user posts them. Then we have a message broker who receive messages and store them. On the other side, we have two consumer application. The first one is mobile app and the second one is an analytics app. Both need messages from Twitter app. Producer app connects to the message broker and starts sending messages. Messages are received and stored by the broker in the order they arrive. Next, consumer application connects to the broker and start consuming messages in order. They can connect anytime to receive messages. When they read the message does not delete. It is stayed in the broker and can be read multiple times. Messages are persisted by the broker with either the expiry time or with a size limit. Let's understand how messages are stored. Messages received in order by the broker has offset assigned to them, an incremental sequence. Using offset, consumer can retrieve message multiple times. Messages cannot be deleted, they cannot be updated or modified, and their order cannot be changed. This is what we call immutable event logs. Okay, let's explore features which makes Kafka different from other messaging technologies. In the world of container and microservices, one can ask how does it scale and provide high availability? Let's assume we have a topic A that receives messages. A consumer can connect and get messages. But what if we want to scale our consumers to increase throughput? We can do this by creating partitions for a topic in Kafka. Produced message will be distributed in these partitions, and multiple instances of a consumer application can connect to different partitions and receive messages parallelly. In case one consumer instance goes down, the existing one will connect to the partition and start receiving messages. What happens if the whole broker goes down? Let's build a broker and call him broker 1. It has all topic and their partitions. When you scale your broker by adding a new node, Kafka will replicate all your topics and their partition on other broker as well. In case broker 1 goes down, broker 2 will be available for producers and consumers to send and receive messages. What we have seen so far? Well, Kafka is based on publisher and subscriber pattern. Messages are always stored as immutable events. Topic partition provides high throughput. Adding nodes in the broker provides high availability. That's it for now. Thank you.